This is during magnetite synthesis. First, as you see it, the color of the solution is what called the green, the reddish color. That's a mixture of what called the iron 3 and the iron 2. Later, after the base was added here, this is a base. This is a base. This nitrogen gas for prevention of oxidation here to be converted into iron 2O3, that's hematite. This temperature for testing the temperature mostly at 80 degrees Celsius will prepare this magnetite here. This is water bath for just indirect heating because direct heating may be cause cracking like that. So to prevent this, we'll use the what called the this water bath with sand, and we'll check the temperature here. This is a nitrogen gas here. Thus, it is a source for prevention of what we call hematite formation. Just it can enter through here, through this side. Then after that, it can be out by this side. This plastic is used to be elongated and to make less contact between the air. That's if the oxygen contact with our solution, that's iron 3 and iron 2, it can maybe easily oxidized. It's better if reaction take place in the foam hood because for safety, if you just synthesize outside, maybe some cracking or like that maybe happen. So just this foam hood, the reaction is taking place in the foam hood. Even the reaction is not this much factor to prevent any what called the gas, volatile gas like that. Maybe just release and removed through foam hood. This, as I said, nitrogen gas is now around 1,000 something like that. 1,800 megapascal, yeah, the bar, and this controller for controlling the what called the amount of nitrogen here. This for opening, you can, if you rotate like this, we can open. If you make like this to the right and the left here, it's opening and closing like this. So this amount of the pressure here, if you observe here, almost we are using zero point something bar is used here, and this is thrown, this one for holding of this nitrogen gas here, secondary what holding because it may be fail and it may be cause another problem. So to prevent this, we will use troll, this one here, nitrogen gas. Is hot plate for heating temperature because the temperature on the hot plate and inside the sample may be not the same. So we must test this one here using two what called the thermometer here. We have another thermometer also here. I test it first. The temperature become 80, then I will start adding sodium hydroxide. So the reaction is taking place here. The reaction is here under steering gear, under magnetic. Here it's almost black. Precipitates, as I think here, we'll see it later maybe. Black precipitate is forming this formation of magnetite. So then after that you can characterize whether it is magnetic or not by using a magnet. We'll test, and if it is attract, we can say it's magnetic like that here. For example, if you see this, what called the nano that synthesized before, if you observe like this here, this one is a magnet, this one, to test whether it's magnetic or not here. If you observe like this, it is attracted toward what? The magnet. So this shows what? The magnetic property. We just synthesize in very well way. Let's here. Let's check again here. Let's check here. This one here, if you observe, it is a stand with what? Toward the magnet. So that's perfectly we synthesize the magnet here by this way. So this is magnetite. You can say iron 3O4 is synthesized by this way. Is a cameraman who synthesized this nanoparticle that's used for different what called environmental application, or medical, for removal of heavy metal, for what called photocatalytic application like that. And we can apply for different purpose here. Almost it is attracted, yeah, as highly magnetic if you observe here. So we easily synthesize by this way and just use it for different application in the laboratory here. And we also characterize by different modern spectroscopic technique like XRD for testing the whether it is magnetic or not, and the another one using same to know the morphology of nanomaterial, same in the EDX that's to know whether the synthesized nanomaterial as magnetite containing what oxygen and iron, because the magnetite means it's made up of oxygen and the what called iron as iron 3 or 4 as spinal or cubic in most of the time. Sometimes maybe other derivative like that of orthorhombic may be synthesized. So uh, just to synthesize by this way, we use in the laboratory this mechanism. We are in the Chulalongkorn University. That's Thailand, the top university in the world right now. Yes, we are doing our research. Our research group is called Environmental Research Analysis Unit Group. Yes, about concerning about different types of removal of different waste from the environment using different technique. For example, the earth treatment by what called adsorption. For example, removal of testing the toluene, for example, here formaldehyde. The material those which are particularly used for this, that's reported mostly in the journal, the silica and the polyvinyl alcohol derived are used here. The other one here will remove the waste of heavy metal like that of arsenic, those which are exist in different oxidation state, silver, sorry, mercury, lead, cadmium, zinc, chromium with a different oxidation state, less plastics and the plus what you call the three here the material those which are used for the removal of such what the heavy metals are mostly reported here as using clay, the humic acid, silica, biopolymer, magnetic nanoparticle, what we have discussed before, activate carbon, activate sludge, and generally they use for wastewater treatment here. The other one is calorimetric detection of what we call the different uh, what we call the environmental application. For example, by forming a thin film and they use for detection of heavy metal according to their color detected here. So parameter, as you know, the pH, for example, the other one like concentration, dosage, and the other. This person is called me. He's my uh, friend, and we are doing together the research in our lab. His name is me. This is a top view of our university. Mini stadium. That's one. We play football there. Enjoy it sometimes. This is sonication. We'll sonicate our sample for mixing sample very well by the action of wave. It have a wave, so the sample can be just mixed and just become homogenized by using the ultrasonication here. What the principle here? They have different unit that you need to be just ultrasonicate. For example, for 5 minutes. If you need for 5 minutes, like here, we can just adjust to this 5 minutes. If you need 10, 50, it's until the half 30 minutes. So yes, you can make, if I need, for example, 30 minutes or 50 minutes, let's say this 50 minutes, I make like this here, then I'll start here, mix it, and homogenize our sample by the action of wave. This is a oven for drying of the sample here we'll use in our lab. Thank you very much for watching us. Subscribe, like, comment, and just for relaxing, for sharing of our experience. Thank you so much.